This is problem 14, which is related to the previous problem. So in this problem, you've got these three different shapes: sphere, a solid cylinder, and then a hollow cylinder. And they're all going to be released at the same time and roll down this incline. And so you want to know, what is a general equation for finding their final velocity at the bottom of the incline? And so you're given there in terms of m, r, h, g, so on and so forth. And so, like I said, it's similar to the previous problem involving, so we're going to do this using conservation of energy. However, pretty much I'm thinking we're going to be able to get the answer just strictly in terms of I. All right? So then let's set this thing up, right? So again, K final plus U final is equal to K naught plus U naught. All right, so here, here's H. That's their height, okay? And they all of these start off at rest. So the initial kinetic energy is 0. Furthermore, if I define H to be 0 at the bottom of the ramp, then the final potential energy is 0. Right? And so that leaves us with the final kinetic energy is equal to the initial potential energy. And again, this final kinetic energy, it's a combination of translational kinetic energy, so that 1/2 mv squared, plus rotational kinetic energy. And that, the sum of those two is equal to the initial gravitational potential energy. Okay. Next. What we want to do here then is looking for V final. So let's do this also. Again, let's realize here that this omega squared, omega is V over R, right? So that means that we can replace that omega with V over R, and that gives us V squared over R squared, right? So then let's rewrite that. All right, and then that is equal to mgh and then we're going to solve for V, okay? So looking at this last one right here, we can factor out that V squared term, okay? So the bottom part here then becomes, let's see, V squared. It's math time, folks. So 1/2 m plus 1/2 I over R squared. Equals m G, H. And so then to get V, divide both sides by determine the brackets here. And you take the square root. And that looks horrific, I know. But that should work. So that means that the equation for getting the final velocity in terms of M, R, H, G, and I is V equals the square root of mgh over 1/2 m plus 1/2 I over r squared. However you manage to enter that thing into your into this program, I will figure out a way to do this and post it. All right, but this is the general solution to that question, for the first part of the question anyway. So it's math and physics. All right.